So let's have a look at what is Hooke's law first. I'm going to get a couple of diagrams to show what Hooke's law is. So what we're saying is that let's imagine we had a spring, and that's its normal length. So it hasn't extended in the first one on the left. Then I'm going to apply a force. In this case, I'm going to put a mass on it, so it pulled it down, and this is now the extension. Okay. Now, if I double the force, I'll double the mass, then the extension doubles. So the Hooke's law simply says that the force, let's write that again. Hooke's law says the force is directly proportional to the extension, which means if I double the force, so I put two of these, I double the extension. Okay. Now, we can also write it as F is equal to K times X, and this K is what we call the spring constant. Now, actually, often they write X, but I think at GCSE you tend to write E for extension. So the E is extension, and the K is the spring constant. So, and it basically is how stiff is the spring, how difficult it is to stretch the spring. If it's really difficult to stretch the spring, it has a high spring constant. If it's really easy to stretch the spring, it has a low spring constant. So we can look at this in a little bit more detail over here. And let's zoom out a little bit. Yeah. Okay, let's zoom back in again. Rise over, okay, yeah, so the slopes, the gradient, rise over run, it basically means a change in it. So we don't want to go too much into this detail, but all it's saying is that if you plotted the force against the extension, it says displacement, okay, force against the extension, it will make a straight line. That's Hooke's law, okay? Very, very quickly, Hooke's law.